Okay, so you should be able to look on D2L and get the key, but I'm going to go through all the test 1 review questions. Okay, so the first thing is number 1 has us sketch the line, but also come up with an equation in slope-intercept form. So you'll need to remember your line formulas. This one is y equals mx plus b, right? And so we put the slope in for m, and we have the y-intercept of 4. And then as far as graphing it goes, on your review you have an actual piece of, or a square of graph paper. But remember, we graph the y-intercept first. So I'm going to use another color here. And then from there we count the slope. So we're going to go down 1 and over 2. So if we go down 1 and over 2, we end up here, and then the line looks something like this. Okay. Number 2, a horizontal line through the point 4,3. Horizontal line equations always look like y equals something, so it's just y equals whatever the y value is for that point. And notice the point for this one is 4, 3. Okay. Number 3, we want through the points -3, 5, and -2, 4. So normally speaking, we would want to use point slope form, which looks like this. Okay, so make sure you not only know the y equals mx plus b, but that you know that formula. But notice we're going to need to find the slope first. Okay, and slope is y2 minus y1 over x2 minus x1. So we're going to find that first. So it's 4 minus 5 over -2 minus -3. Notice it's x2 minus x1 and happens to be negative there. So this is going to be -1. That's going to change to -2 plus 3. So it's going to be a slope of -1. So now that is just the slope that gets put into this equation. So it's going to be y minus, and here's where you'll pick any of the 2 points you want. So I'm going to choose this one. Y minus 4 equals -1 times x minus the x value. And then if we clean this up, we'll get negative x minus 2, because that changes to plus 2, and then you multiply by the -1. And then if we add 4 to both sides, we get what's on the key, which is y equals -x plus 2. Okay. Now, I picked the point -2, 4, but just know that if you would have picked this point, the steps might have looked different, but in the end you would have ended up with that same exact result. Okay, so number 4, we are given a couple pieces of information, and we're supposed to find an equation given the company's sales as a function of time. Okay, and so we have to first figure out what the slope is, but we're going to try to use y equals mx plus b. Okay, but I am going to need to find the slope. So over off to the side, let's talk about the slope. It is the change in y, which in this case is the change in money over the change in x, which in this case for this word problem is the change in time. Okay, so if you look at the quantity of money, we have 7.4 minus 2.4, because it's the ending money value minus the beginning money value. And then as far as the years go, you can either say 5 years have passed, or you can literally do the years like this. It's 2011 minus 2006. Okay. At any rate, you're going to get 5 over 5, which is the slope of 1. So we come back here and we say, okay, it's going to be y equals 1x, and then plus the y-intercept. And the y-intercept is always the starting value of the problem. So if you look at the starting quantity, it was that 2.4 million that the problem says the sales were in 2006. So this is part A. And then part B says what were the sales in 2009. So you have to read the problem, but if you read the problem, it starts in 06. So if we go 2009, it's 3 years later. So you're just going to plug in 3. So it's going to be 1 times 3 plus 2.4 or 5.4. And then make sure we label, right? It's in millions of dollars. So it's not just $5.4, right? It's $5.4 million. So consider number 4 kind of like an application of the linear problems before it. Okay, so for the next few problems, for 5 through 7, I want to talk about domain. So remember we talked about this in class, but the denominator cannot be 0. That is one element of the domain we have to be on the lookout for. And also we want to take positive square roots only. Okay, so let's see if we can work out 5 through 7 using these basic pieces of information. Okay. In other words, remember domain is the x values that are allowed, and I'm trying to tell you what we want to look out for, situations that we want to be aware of. So in the first one, f of x equals the square root of 5 minus x. Okay, I really, really want to make sure that this is positive. Okay, so I want to make sure that 5 minus x is greater than or equal to 0. That's the mathematical way to say positive. So I'm going to subtract 5 from both sides, and I get negative x is greater than or equal to negative 5. And then if I divide by negative 1, remember that when you divide a greater than, less than problem or multiply by a negative, it changes the sign. So I end up getting actually x is less than 5. Okay, so if we have a number line, we want to include 5 and we want to go less than that. So what I want to see is interval notation for these answers. So I want the all the numbers from negative infinity to 5, including 5. Okay, so if you're a more visual person, I think the picture helps, but the picture is really not mandatory. Okay, but what is mandatory is this interval notation right here that I circled. So in number 6, we are concerned about the bottom being 0. So before we can worry about that, we need to factor the bottom. Okay, so I'm not going to spend a whole lot of time on the factorization of this. Just know that you need to use AC method. But this factors into 2x minus 3 and x plus 1. Okay, and now we want to make sure that neither one of these are 0. So 2x minus 3 shouldn't be 0, but also x plus 1 shouldn't be 0. Because if it is, it's going to make the denominator 0, and that's off limits. So x can't be 3/2, but here x can't be negative 1. So again, I'm going to draw a picture, and I'm going to tell you that the picture is optional, but I do think the picture helps you get where we need to go, right? We want to not allow these numbers, but we do want to allow everything else, everything this way, everything in between, and then everything to the right. So what is required is this, the interval notation. So it's negative infinity to negative 1, not including negative 1, so use a parentheses. And then from negative 1 to 3/2 in between the two. And then finally from 3/2 to infinity. Okay. Notice that I don't use brackets on anything because I actually want to make sure these are not included. I want to specifically actually exclude them. So when you look at number 7, hopefully you recognize number 7 as a polynomial. Oh, actually number 7 isn't domain, sorry about that. But if I did ask you to find the domain of this, it would be all real numbers because there wouldn't be a denominator and there wouldn't be a square root to worry about, so it would just be all real numbers. But number 7 transitions to something else, so I apologize about that. So we're supposed to find f of negative 2. I'm going to skip some space. F of 0. And then finally f of a plus 2. Okay, so f of negative 2 has you plugging in negative 2 everywhere there's an x, right? That's what f of something means. It means go to the f equation and replace x with whatever is in the parentheses. So it's going to be 2 times parentheses negative 2 squared plus 5 times negative 2 minus 3. Make sure you remember your order of operations. I should be doing this first before I worry about multiplication. So negative 2 times itself is 4, okay, because it's a negative times a negative. 4 times 2 is 8. This time, 5 times negative 2 is negative 10. And then we have the minus 3. So this is negative 2 minus 3, which is negative 5. Okay, so make sure that when you use your calculator, you put the negative 2 in parentheses. Okay, so I think we've talked about that in class before, but when you're using your calculator, you want to make sure that you're really clear. So let me show you what I mean by that. So note, if you just do what I've seen a lot of students do, let me get it out of the glare, and do negative 2 squared, Okay, the calculator is going to come at you with that's -4 because it's doing the squared and then it's applying the negative. Okay, what you want it to do is do -2 in parentheses squared, like the whole thing, the sign and all. And then notice if you do that, you get +4. Okay, so a good rule of thumb with your calculator is just to surround anything that's negative, especially with parentheses. All right, so let's plug in 0. It's generally pretty easy to plug in 0. Okay, so if we plug in 0, these things go away, and I'm just left with -3. All right, so this one, I probably should have left myself a little bit more room for this. So this is f of something, so it just means go into your equation and replace x with that a plus 2. So instead of 2x squared, it's going to be 2a plus 2 squared plus 5 times the a plus 2 parentheses and then -3. So expanded out, it's going to look like this. 2 times a plus 2 times itself, and then plus 5 times a plus 2 minus 3. So we're going to want to FOIL, and then we'll distributive property. We're going to need a distributive property here, but also the 2 will need to distributive property there. So I'm going to kind of quickly go through FOIL. So you need to make sure you can do the first outside, inside, last here. But you get a squared plus 4a plus 4 if you were to do FOIL. Okay, notice that's the only thing I did there. And then now we're ready to do the distributive property. So you end up getting 2a squared plus 8a plus 8 plus 5a plus 10 minus 3. So I sent the 2 to everything in this parentheses and the 5 through to everything in this parentheses. And then just combine like terms if you have any. So we have 2a squared, we have 8a plus 5a, which is 13a. We have 8 plus 10 minus 3. So 8 plus 10 is 18, minus 3 is plus 15. Okay, so that one was a little tougher, right? We have to remember that we cannot, I repeat, not distribute a squared if that's what you were tempted to do. You have to do a plus 2 times itself and actually FOIL it. Okay, so keep that in mind when we look at what I'm asking you for in number 8. So this formula is called the difference quotient. Okay. So my strong suggestion to you is to do baby steps to this problem. In other words, this looks a little ugly, so I'm not going to try to tackle the whole thing. I'm going to break it down into pieces. So I'm going to do f of a plus h. Okay. So that means go to my f equation and stick in a plus h. That's what it means. So this looks like 4 minus a plus h times itself. So again, I'm going to do FOIL here, but I'm going to worry about the 4 minus thing after. So this is 4 minus, and then do FOIL. A squared plus 2ah plus h squared is what you'll get if you do FOIL. And then don't forget this negative sign is actually going to alter the sign of everything, right? So we actually get 4 minus a squared minus 2ah minus h squared. Okay, so I'm going to circle that, but that's not my final answer. That's just my f plus h part. Okay, so now let's see if we can find the f of a part. So f of a just means plug in a, right? So in place of x in your original 4 minus, my whiteout pen decided to not work on me. So in place of the original x, we're just going to put a. So notice that's actually even a lot easier than what we were doing. Having technical difficulties here. Hang on a minute. There we go. All right, so it's going to be 4 minus a squared. Okay, so instead of 4 minus x squared, we're sticking in a. Okay, so now let's see if we can do the full-blown kind of uglier looking function here. So I'm going to do a bunch of stuff over h, so I'm just going to start there. So the first thing is I'm going to start off with what I got for this piece, right? I got this for f of a plus h. And then I'm going to subtract off this piece, right? I got 4 minus a squared. But then if you notice, if you change the sign of everything, right, like this is going to send through to here, so this is going to be negative and this is going to be positive, okay? Well, that means that it's going to cancel with this. This is going to cancel too because you have a negative a squared plus an a squared, so you end up with just negative 2ah minus h squared. All of that over h. Notice it's getting smaller and more compact as we go. And then last but not least, we have an h in everything, so I'm going to cancel one h out of every term. So we end up with negative 2a minus h. Okay, so kind of a long, drawn-out problem, but remember what I told you in class, like this has some significance. So when you get to the class after this one, you're actually going to talk quite a bit about this specific difference quotient equation. But for now, we're just treating it like an algebra problem because that's what it is. Okay, so let's look at number 9. So I asked you to find g of negative 1. I asked you to find g of 4. And then we're going to go ahead and answer C first. What is the name of this type of function? It's a piecewise function. So it is literally a function in pieces, but remember it just represents a pattern change. In other words, we're going to follow this pattern as long as x is less than or equal to 0. But then when x gets greater than 0, we're going to switch over to this pattern. Okay, so when you're asked to find g of negative 1, it's kind of like number 7, okay, but you have to decide which pattern is it appropriate for me to use, okay, and it all has to do with the x value that you're given. So you have to ask yourself, is negative 1 in the less than or equal to 0 category, or is it greater than or equal to 0? And notice that it's actually less than or equal to 0, right? So I'm going to say since negative 1 is less than or equal to 0, I'm going to use equation 1. Okay, so I'm going to plug in this number, so negative 1 squared plus 1 would be 1 plus 1 or 2. All right, so this one, g of 4, notice that 4 is greater than 0, right? It's not less than or equal to 0, so we're not using pattern 1, we're using pattern 2. So since 4 is greater than 0, we need to use equation 2. So notice we make the decision on which equation to plug it into at the beginning. We do not, and we never, ever, ever plug it into both and then try to decide after the case or after that, because that would mean it would no longer be a function. We would be repeating our x values. So you don't ever, ever do that. Okay, so number 10, you probably will have the graph of a basic function where you have to tell me if it's a function, first of all, and then what the domain and the range is. Just plan on that looking different necessarily than what I gave you on the review. So here's the review, right? So the one that I give you on the test is probably not going to look just like that. Okay, so just make sure you know how to do domain and range all over the place, no matter what it looks like. So this is a function, okay, because it passes the vertical line test. You also could say there's no x repeated. But when you're given a graph, it's usually a visual vertical line test that tells you whether it's a function or not. So remember, domain are the x values, and range is the y values. So for domain, we go left to right. So you have to ask yourself, how far back will this graph go to the left, and how far to the right will it go? And the answer is forever. Okay, so it's negative infinity to infinity. And then for range, we look bottom to top. Okay, so if you look at the range, or if you look at this graph from bottom to top, notice it's going down forever, also going up forever. Okay, so the range would also be negative infinity to infinity. Okay, but we practiced some different types of graphs in class and actually on your competency exam. So make sure that you know domain and range no matter what kind of function I might throw at you. Okay, so use the above graph, and I asked you to find f of negative 5. I asked you to find f of 4. And then I asked you for what x is f of x equal to 10. Okay, so you're supposed to use the graph, so I don't want to put that back up there. But remember, this is f of x, or f of a number is really saying what's the y value? So this is asking for the y value when x is -5. Okay, so if you look at your graph, okay, when x is -5, it looks like y is 0. So the answer to f of -5 is 0. Okay, so you just have to know that this is what it's asking for, right? So this is asking you for the y value when x is 4. So when x is 4, notice that the y value is also 0. Okay. But then I'm switching up what I'm asking you about here. I said for what x is f of x equal to 10? Okay, so this is actually giving you that y is 10, whereas here I was giving you x within the parentheses. Here I'm asking you to find what would be in the parentheses. Okay, so you're looking for a height of 10, and then you just have to match that up with whatever x value it is. So if you look at your graph, that occurs at x equals 6. Okay, if you look at x equals 6, it goes up to 10. All right, number 12, the average life expectancy after age 65. Okay, so there's lots of stuff going on here, but let's write down the gist of the equation. So here is the life expectancy formula after age 65. So in other words, the time is not how old the person is, it's how many years past 65 they are. Okay, and then L of t is the life expectancy. So when you look at A, okay, it asks you how fast is the life expectancy after 65 changing at any time, okay? So when you see how fast, that terminology means a rate of change. I can get my whiteout to work this time. And a rate of change is just a fancy way of saying slope. Okay, so there's not really any figuring to do on this one. It's really just asking you which of these numbers is the slope. Okay, and of course the number in front of the variable is in the slope location, it's the m. So the answer to A is just whatever the slope was for that line, which was 0.056. And then in part B, it asks about 2010. Okay, so if you go back and read the problem, we are starting in 03, and they're asking about 2010, so this is going to be 7. Okay, so you're just going to use that equation and plug in 7. So you're going to find L of 7. So it's 0.056 times 7 plus 18.1. So let's talk about what we get and then talk about what it means. You're going to get 18.492, but that doesn't make sense that that's the life expectancy of a person, right? Because that's a really small number, right? That would mean, you know, after they become adults, they're, you know, expected to not make it much past that. So remember, if you read the problem, it's actually years after age 65, so you have to add 65 to that. So it's actually 83.492 years. So that's kind of an application of linear equations, and so is number 13. Okay, so let's look at that one. Number 13 is a depreciation model, so you have to figure out, you want to use y equals mx plus b. Okay, the only thing about this with depreciation is this is going to be negative. If it's depreciation, the values are going down, so the rate of change will be negative. Okay, so let's keep that in mind. So let's see if we can find out the slope. Okay, so we want the change in value over the change in time. Okay, the change in y, but for this problem it's the value of the car, and then the change in time. So notice that we are going to completely depreciate this car in 4 years, which means it's going to lose all of its value. Okay, and then the time period that is passed is 4. So what you end up getting is 8,000 per year that it's going down. So if we want to come up with an equation, we kind of already did one like this, it just wasn't a negative slope. So it would be negative 8,000 x or t, however you want to say it. Probably we would use t, but I think the key says x, but it doesn't really matter. And then what goes here is the starting value of the car, which was listed at 32,000. Okay, so that's part of what I asked for. So then after 3 years, I am asking you to use this equation and plug in 3. So negative 8,000 times 3 plus 32,000. So that's negative 24,000 plus 32,000, which is 8,000. So basically, you only have 1 more year left is essentially what it means. So you only have 1 more of those things that are worth 8,000. Okay, so on number 14, I'm going to show you, we're going to describe what's happening, and then I'm just going to show you my key. Well, I don't know. We'll figure it out. So for these changes, first we need to discuss what change needs to be made, and then we'll try to sketch it. All right, so this is an up 2 shift. And this is remember this works opposite in the way you might think, so this is a right 1 shift, okay? So if you were describing what was happening, remember there is an order here. You actually need to shift right 1 first, and then followed by up 2. So you are going to kind of sketch that out. So I'm going to try to put them all on the same graph. So I'm going to take my review here and see if I can do it. So here's the original graph, right? I know it's kind of light, okay, but I need to shift it right 1 and up 2. So this is going to be right 1, up 2. So this point becomes right here. This one is going to go right 1, up 2 again. So I keep forgetting what I'm doing. So this point's going to go right 1 and up 2 to here. This point's going to go right 1 and up 2 to here. And then the point that was here is going to go right 1 and up 2 to here. So we end up getting the same shape, just shifted up. Okay, so this is part A. Okay, so let's look at B. And then we're going to go back to that same graph. So for y equals negative 3 times g of x, okay, there's actually 2 changes occurring here. 1 because of this negative sign, and then 1 because of this 3. Okay, so the negative sign in front is a reflection over the x-axis. Now remember, I handed out a handout, and it's on D2L also, but there's a handout that tells you like the basic graphs, and then we talked about the 6 transformations. Okay, so so make sure that you kind of look at that handout also. And then a number greater than 1, okay, because the negative is a reflection. So a number greater than 1 means that it's a vertical stretching. So it's a vertical stretch by a factor of 3. So in other words, it's making it 3 times taller. Okay, so if we go in order, remember there is an order that I gave you for this as well. So if we go in order, we're going to vertically stretch it first. And then we're going to reflect it. Okay, so I'm going to get a different color writing utensil so we can do kind of a different color every time. But our graph's going to look a little ugly when we're done. Okay, so we're coming back here and we're going to stretch it by 3, and then we're going to reflect it over the x-axis. Okay, but notice if you stretch 0, it stays at 0, and also if you flip 0, it stays at 0. So these points that are the x-intercepts actually aren't changing. Okay, they're staying. So we're more concerned with the tops of these triangles. Okay, so this is a current height of 2 downward, right? So we need to go to a height of 6, which takes us a little bit lower than the graph, and then we need to flip it over the x-axis, so it's going to end up here. Okay, same thing here. We're going to triple it, right? Triple the height, and then we're going to move it down here. So notice B's graph ends up looking like this. Okay, so notice the width doesn't change, but the height is 3 times taller. Okay, and it's also flipped. So that's that one. So on the key, if you go look on D2L, the key has them separated out, which is going to look a lot better than what I'm doing here. But I don't really have 3 copies of it, so that's why I'm doing them all in the same one. So this one only has 1 change. Just remember that horizontal stretches and shrinks work the opposite way that you might have thought they would. So this is just going to be a horizontal shrink of 1/2. Okay. In other words, we're making it half as wide. That's a kind of general way to say that. So we're not changing the height, we're just changing the width. All right, so this is pretty ugly. But let's go ahead and change the height, and hopefully you can see where the original was, right? Or not change the height, but change the width. So notice that 0 is going to stay. Okay. What did have a width of 2 is going to be reduced to 1. And then notice the height's not changing either. So I'm losing track of what my graph was, but so basically it is the same looking graph, but it's just more narrow. Okay. So those are kind of strange, but like I said, look at the key that I have on D2L, and I think that'll be a little more clear because at least they're separated out instead of being all crammed together on one graph like those are. So make sure for question number 14 that you know all 6 transformations. Okay, I think we did almost all of them. I think the only one we didn't cover was a reflection over the y-axis. Okay, so make sure you look back at all of those. All right, so number 15, I do want you to know kind of all things parabola. Okay, so first let's start off with how to find the intercepts. Okay, you always find intercepts by setting the other thing equal to 0. So here we're going to set y equal to 0. Here we're going to set x equal to 0. So if we set y equal to 0, notice we're going to have a factoring situation. But we don't need AC method when the coefficient in front of x squared is 1. Okay, so all we have to do is just think about what are the factors of -6 that add up to 1. So it's going to be +3 and -2. So I end up getting -3 and 2 as my x-intercepts. If you're asked to write them as points, make sure you can do that, but it would be -3, 0 and 2, 0. So that is where it crosses the x-axis. Where it crosses the y-axis is what I get when I plug in 0 for x. So 0 squared plus 0 minus 6. So it's y equals -6, or in point form, it would be 0, -6. But then make sure that you remember the formula for vertex. Okay, you're going to need that for actually more than one question on this review, and I'm not sure how many questions might be on there for the test. So for the vertex, when it's in this format, we use the formula -b/2a to find the x part of the vertex, and then we plug that in to find the y part of the vertex. So we've got -1, because b is 1, over 2 times a, which is also 1. So we get -1/2, okay, but that is just half of the vertex. I always have students like stop there, but you still need to find the y, okay, and you find the y by plugging in that -1/2. So it's going to be -1/2 squared plus -1/2 minus 6. Okay, so let your calculator do that. So -1/2 squared plus -1/2. So I'm putting it in my calculator now. So you get -6.25. So if we had to come up with a point, it would be -0.5, -6.25. Because when we get to the graphing part, we're going to wish that we had it in decimal form probably. So on your review, you have a grid, so use it, okay, but I'm just going to sketch it. So it crosses the x-axis at -3 and 2. It crosses the y-axis at 6. But make sure you actually mark the vertex. It's an important part. So it's back -5 and then down a little bit more than 6. So make sure you actually turn at the vertex. Notice I don't actually turn at the y-intercept, and that's kind of a common mistake. So make sure that your parabola turns around at the vertex. Okay, so we also have parabolas that might look like this instead. This is what we call vertex form, and it's literally called that because you can get the vertex from it very easily. So we're just going to start there. When an equation is in vertex form, okay, you can just pull the numbers here, and the formula is always the negative version of this number, comma, this number. So the vertex is literally 2, 4. Okay, let me circle my vertex up here. And then the y-intercept, I find that by setting x equal to 0. So I just need to do g of 0 and be careful with everything. So I get negative parentheses 0 minus 2 squared plus 4. So if I do parentheses first and then square it, I'm going to get 4, and then it's going to be negative. So negative 4 plus 4 is 0. So this is just the point 0, 0. And then lastly, for my x-intercept, we're going to set y equal to 0. So let's do that, and let's try not to have to FOIL that out because we really actually shouldn't need to. So if you were going to solve this for 0, you would subtract 4 on both sides. So I get negative 4 equals negative parentheses x minus 2 squared. I'm trying to get the squared thing all by itself. So then I'm going to divide by a negative 1. In other words, get rid of the negative signs on both sides. So I get 4 equals x minus 2 parentheses squared. And then I say, okay, what I'd really like is to have that squared gone. So when you take the square root of both sides, remember that you have to say plus or minus. So what you end up getting is plus or minus 2 equals x minus 2. And then if we add 2 to both sides, we get 2 answers. Okay, we get 2 plus 2, which is 4. And we get 2 minus 2, which is 0. Okay, so we actually get 2 intercepts. We get one at 4, 0, and one at 0, 0. And we also should know that the parabola is going to open downwards. And we know that it opens downward because of that negative sign in front. So it opens downward, which means we have a max, and the max is that vertex. Okay, if it opens upward, we have a min. Okay, so taking that thought, let's go into number 17. So number 17 has a profit equation that is based on how much advertising a company spends. So it asks you for the max profit. So it asks you for the max advertising and the max profit. The key word I'm wanting you to see here is that it's max. Okay, so notice this is an x squared equation, so the parabola is going to be opening downward because of this negative here. Okay, we know that it's opening downward because of that negative. So when you're asked to find the max, that is just a fancy way of saying, hey, find the vertex. And we have a formula for that, right? It's x equals negative b over 2a. But notice they didn't come right out and say, hey, find the vertex of this curve. But because it's an upside down parabola, the max is the vertex. When it's a upwards facing parabola, it's the min is the vertex. Okay, so let's do that. So negative b over 2a. So it's going to be negative 7 over 2 times negative 1 over 8. Make sure in your calculator that you put parentheses around that whole bottom. But what you should get here is 28. So in order to answer part of the question, make sure you read it. It's 28,000 that we spend in advertising because X in this problem is in thousands. So that's part of what I asked for. And then the other part is what would happen if we did spend 28. So in other words, tell me what the profit would be if X were 28. So we're going to use our calculator for that. So negative 1/8 times 28 squared plus 7 times 28 plus 30 on the calculator ends up being 128. Okay, and so this is in thousands also. So it's 128,000 in profit. In other words, if they're trying to maximize their profit, and most business owners are trying to do that, right? They want to spend 28,000 in advertising because that's going to yield them 128 in profit. All right, number 18. So find the degree of the polynomial. So remember, degree is the highest power that we have. So what you have to do is you have to go through and kind of count what the total power would be if you were to multiply them out, because we don't want to do that. Think about how ugly FOIL would be just for 4x minus 4s, and then you'd have to multiply it by x squared minus 25. Like, we don't want to do that, right? So we just need to ask ourselves, like, what would be the degrees if we did combine all of these, right? And it would be 3, 5, and 2, which is a total degree of 10. Okay, so it's going to be a 10th degree polynomial. And then notice it asks you for x-intercepts. Okay, but let's not make that harder than it is. Like, we already have this almost all the way factored. So we would just do 0 equals x cubed times 4x minus 1 to the 5th. And then this is x squared minus 25. So the only thing that I would say is I think we can do something with the x squared minus 25. Remember, this is a difference of 2 squares, so it actually factors into x plus 5. X minus 5. Sorry, that was supposed to be a 5. But everything else is already factored, so we're not going to mess up what we got given to us, right? It's supposed to be a 5. The whiteout is not doing so well. So we set each one equal to 0, so if you set x cubed equal to 0, you get 0. If you set this one equal to 0, you get 1/4. This one equal to 0, you get negative 5. And then lastly, x minus 5 equal to 0, you get 5. So if I asked for points, you would say 0, 0, 1/4, 0, negative 5, 0, and 5, 0. And then the y-intercept, we always just set the x equal to 0. So h of 0 is going to be 0 cubed minus 4 times 0 minus 1 parentheses to the 5th times 0 squared minus 25. But you don't need to mess with any of this because 0 is going to get multiplied by it, and it's just going to be a big fat 0. So the y-intercept is the 0.00. Okay. I probably would never ask you to graph any of these, but I might ask you some things about the graph like I did in the next problem, number 19. Okay, so number 19 said, what is the maximum degree, what is the minimum degree of the polynomial function? Could have at the right, and then is the leading coefficient negative or positive? Okay, so what I wanted you to do with this graph, okay, so here is the graph. Okay, and I'm going to kind of cover up the answer here. So I wanted you to look at the graph and see how many times it crosses the x-axis. How many x-intercepts does it have, in other words? So notice that it has 5 x-intercepts. Okay, so it's an odd degree. And I also want you to notice that the graph goes up to the right and down to the left. Okay, so the odd degree, notice that it already is odd, right? So that means the minimum degree is going to be 5. Okay. Because remember, we have a rule that says that the degree, you can't have any more roots than the degree is. So it might be higher, but the minimum would be 5. And then the leading coefficient would be positive. The leading coefficient is positive because of the second piece, the graph going up to the right and down to the left. So if it were opposite, if it were down to the right and up to the left, it would be a negative leading coefficient. Okay, so if you want to remember, we had 4 cases for end behavior, so you might want to look back at those in your notes. Okay, if it was an odd degree and a positive leading coefficient, the graph did just what this one does, up to the left, up to the right, down to the left. If it was negative, it did the opposite. And then if the degree was even, remember they both go up or down depending on whether it's positive or negative. All right, so we're going to do 20 and 21, and then I'm going to do the rest on another video because I can only record an hour at a time. All right, so let's look at 20 and 21 because they're both asymptotes. That's why I kind of want to keep them together. So for A, we have the function 5x cubed plus 2x minus 3 over 4x cubed minus 8x minus 9. Okay. Notice that the powers are the same. And when the powers are the same, to find the horizontal asymptote, we just pull the top numbers off. So it's basically the horizontal asymptote is y equals 5/4. Okay, not just 5/4, it needs to look like y equals 5/4. But for B, notice that this function, my power on top is bigger. So if the power on top is bigger, then there's no horizontal asymptote. If the power on top is smaller, the horizontal asymptote is 0, by the way. So for these both, you just need to remember that there are 3 cases. Okay, for horizontal asymptote, there's only 3 options. It's either none if the power on top's bigger, 0 if the power on top's smaller, or if the powers are the same, then it's the leading coefficient of the top over the leading coefficient of the bottom. Okay, so to find horizontal asymptote, you find 3 cases. Okay, there's only 3 options, basically. All right, so for 21, for the vertical asymptote, you are going to, or you're supposed to simplify, then you're going to set the denominator equal to 0. So for 21, I need to simplify first. So notice the top could already be factored. So I'm going to go ahead, the top is already factored, I mean. I'm going to go ahead and factor out the bottom. It's going to be x plus 2 and then x plus 4. Notice that doesn't simplify with anything on the top, so we end up just getting that x is negative 2 and x is negative 4. In other words, the vertical asymptotes are the very spots where we can't have the bottom being 0 because those are going to be, remember, asymptotes are parts the graph skips over. So it's going to skip over negative 2, it's going to skip over negative 4. So in B, we have h of x equals 2x plus 3 over x cubed minus 25x. So the first thing I hope you can see is that we have an x that could be pulled out. And if we do, we end up with this difference of squares, right? But then that further factors into x plus 5x minus 5. We've actually already had this exact difference of squares today. So notice there's no simplification we can make on the top. So we end up having 3. X equals 0. You can't forget about this guy. Okay, you set that equal to 0. You set this equal to 0, and you get negative 5. And then finally you set the last one equal to 0, and you get 5. Okay, so that's how you find asymptotes of those rational graphs. So I lied. We're going to go to 22 just because if we go to 22, then we've covered all the rational function graphs, and then we can start with systems on 23. All right, so the last one for this video. So notice we already did this one, so I'm going to go ahead and factor it again. We already did this one in 21A. So I'm going to leave it factored, but for the x-intercept, you always set y equal to 0. But when it's a fraction, so let's set this fraction equal to 0. When you have a fraction equal to 0, though, you really just care about the top equaling 0. Okay, because we can't have 0 on the bottom, but 0 on the top means the whole thing's 0. So if you set the top equal to 0, you're going to get negative 16. So if we were writing it as a point, it'd be negative 16 comma 0. And then the y-intercept is always just setting x equal to 0. So we're going to do f of 0. So we get 0 plus 16 over, I'm going to use my factored form, but you could actually use the original too and it would work. So I end up getting 16 over 8, which is 2. So that would just be the point 0 comma 2. Okay, so for 23 on, you're going to watch the second video.